integers being numbers in a row, or integers being numbers that aren't fractions, like 0, 1, 2, 3, 4, 5, and the negative versions thereof, can be expressed or explained as consecutive, being in a row. So what you're learning today, and what you might, while you might think it pointless, it teaches you a method of thinking that is extremely helpful. So example 1, I want to talk about example 1. And you know what? My example 1s are the exact same thing as the book example 1. You know what? No. Here, I'm going to just use this. All right. So theirs you can look at any time. Here's mine. Write the next 4 integers in natural order after D. What? So if D is the first one, like say 0 is the first one, then how do I get from 0 to 1? Any ideas what I can do to D to increase it by 1? D plus 1 will get you to the next one. And they want 4 of them. So if this is the first one, this is the second one. These aren't evens or odds. These are just like in order. 1, 2, 3, 4, 5. So again, starting with this one, D plus 1 is next. D plus 2 is the third one. D plus 3 is the fourth one. So these are all based off of D and then the next integers in order. Okay, that's all this represents. It doesn't tell us anything. It's just a way to represent. So think about how old you are right now, your age. Assuming I don't know, I'm going to say you are A years old, right? Next year you'll be A plus 1, A plus 2, and so on. Okay, so all this is doing is teaching you a way to represent information. Using this same information, what number precedes D? Okay, so this is the first part of example 1. D minus 1, very good. In other words, how old were you last year? A minus 1. Back to the age example. What number precedes D? D minus 1. So those are integers and describing them using variables. How is that useful to us? Well, it might not loom immediately clear, but we're going to talk about it nonetheless. Here's my next example that I want to share with you guys. And this is my example 2. Write, that should be a TE, an equation stating that the sum of 3 consecutive integers is 24. Okay, so you know how on the previous page we did D was the first one, D plus 1, whatever. Let's start with X. X is the first integer. The next one in order is X plus 1, right? And then we have X plus 2. So this is the first integer. This is the second integer. And here we have the third. How can I use this to represent the sum of those is 24? What can I do to connect that and turn it into an equation? What do you think, Philip? What can we do? Well, is 24 means, yep. And how can I add these three together? What can I put in these spaces? Yeah. There's your equation. You could solve it too if you wanted. Combine your x's, combine your numbers, and solve. You could do that. We can do that real quick, as a matter of fact. Combine our x's. Yep. Subtract 3. Divide by 3. So if the first integer is 7, what's next? And then? So this is the solution set that satisfies that if they asked what are the integers. Okay, if they asked you what are the integers. Okay. Got some more examples that are not in your thing, but I'm going to do them anyway. Here we go. And I'm going to call it example 3. You can call it whatever you want. The product of two consecutive odd integers is 99. Give me the equation and the answer. Okay, first off, let's use n and create two consecutive odds. If n is the first one, if it's an odd number, let's just say it's 3, how do I get to the next odd number? How much must I add? 2. 2. So if you have an odd, let's just say it's 3. In order to get to the next odd, you have to add 2. By the way, the same thing applies for evens, because your starting point, whether it's odd or even, remains odd or even as long as you keep adding 2. Okay? So again, assuming it was 3, then this one would be 5, and that would be true. Okay? This was just kind of a assume thing. Why that's happening. So, the product of these, what does product mean, folks? Multiply. What number, when I add 2 to it, then multiplied together, will achieve a 99? You guys actually don't know how to solve this type of an equation yet, but you could probably figure it out. What are the factors of 99? Let's say 1 and 99, right? 2, no. How about 3 and 33? 4, no. 5, no. 6, no. How about 9? 9 and... Oh, look. 2 odd integers, 9 plus 2, that when multiplied give you 99. So the solution set to this would be 9 and 11. 9 and 11. They are the two consecutive odds whose product gives you 99. Now in your assignment today, I have you doing the evens, but I want to look at a couple of odds really, really quick. All right, so I'm going to flip. I'm going to keep going. This is number 13. 13, you guys can see it. The sum of 3 consecutive odds. So sum means add, right? The sum of 3 consecutive odds is 40 more than the smallest. What are the integers? They give you options. They say, is it 13, 17, or 25? Which one's the smallest? Okay. First, starting with z. We need 3 consecutive odds. If the first one is z, what's the second one? And then? You're right. The sum of 3 consecutive odds is 40 more than the smallest. Which one of these is going to be the smallest? Z. 40 more than the smallest. The sum of 3 consecutive odds is 40 more than the smallest. In example 13, they say, could it be 13, 17, or 25 for the smallest? Well, you could either test it by plugging in, or you can solve it. 3z plus 6 equals z plus 40. When I have z's on both sides, the easiest way is to combine them. So I'm going to subtract z to my left, giving me 2z on the left, no more z on the right. Remember, that's a positive if there's no negative in front of it, which is why I did the opposite. So 2z, I'm going to subtract my 6's over, my 6 over. And I should come up with something that looks like that. Dividing by 2, I end up with a 17. Now, if you don't feel like this is comforting or comfortable for you, you can test each one of these. You can plug in 13 here, 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 and here, and see if it's true. Like this. 13 plus 2, 15 plus 13 plus 4, 17 is the smallest number plus 40. So I'm testing this right now. So I've got 30, 45 equals 43. True or false? Yeah. So the answer is not going to be 13. Okay, I've already shown you that the answer is 17, but let's test 25 anyway. 25 plus add 2, 27 plus add 2, 29 is 25 plus 40. 27. Thank you. So we're testing this one. So 55, 65, 75, 74, 81. Can someone check my arithmetic on the left? We good? Mm-hmm. So, nope. So the answer does not equal 25. So this is how you can do the test method and find out your answer. Or you can simply solve it as an equation and find out what value would fit for z. Okay, that is number 13 in your textbook. Here's 15. Probably the toughest one in the group today. Find 2 consecutive integers. Okay, so q plus 1. There are 2 consecutive integers. Nothing even or odd about them. They're just normal numbers. Find 2 consecutive integers whose product is, so product is 5 less than, so 5 smaller than 5 times their sum, q plus 1. So this is 2 consecutive integers that are 5 smaller than 5 times the integer's sum. Okay, ran out of room now on this side. I'm gonna have to go to the back. Really quick. So q times q plus 1 is 5 times, what was it, 2q plus 1 minus 5. Some of you might be thinking this is impossible. This is the sum of the integers. I'm going to try and simplify this by distributing 10q plus 5. Here's 10q plus 5 minus 5 equals q plus 1. The 5's cancel out. So the easiest version of this equation is q times q plus 1 has to equal 10q. Q times q plus 1 has to equal 10q. My choices are 0, 6, or 9. 0, 6, 9. So 0 times 0 plus 1. Does that equal 10 times 0? Yeah, we already found it. So 0 is the first one. If 0 is the first one, that means 1 is the second one. Okay? So don't get too bound up in all the descriptions. Take each piece. 2 consecutive integers, okay? Whose product, multiply, is equals 5 smaller than 5 times the sum of these guys. Okay?